The encryption algorithms that we talked about 2 slides ago, there are 3 types. One is called hashing. And what hashing is it creates a unique fixed length signature for a message set or data. So think of it this way. If we have a sentence that says, "How now, brown cow," and we basically run it through this algorithm, it will encrypt it and create a whole new sequence of characters. What ends up happening is there's no way to decrypt that information because it's what's called a one-way hash. What will happen is that if I want to verify, and this is used in passwords, so let's say my password was "How now, brown cow," I would then put in, when I'm asked for the password again, I would put in "How now, brown cow," and it would encrypt it using the same algorithm. And then what I would do is I would compare what I just put in that was encrypted to what was stored that was encrypted. And if they are the same, then I know that this is the person who says they are, or at least they have the password. So some of the types of algorithms are, you'll hear these concepts of MD5 and SHA. A symmetric encryption algorithm is a little bit different because it does something like a private key, it's private key cryptography, and they've used it for a very long time. And what it is we both share a key. So I'll take that same message, "How now, brown cow," and I will encrypt it using a key, and it will create the ciphertext. That ciphertext is sent to someone else who shares that key. And once they have the key, they can actually use the same algorithm and the key to decrypt the message. This is not very different from a Captain Crunch decoder ring, or one of the decoder rings that you get in the cereal box. The problem with this type of symmetric hashing is that I'm either going to have the same key with everybody, or if I have different keys, I run into the problem of key management. How do I remember whose key belongs to who, and do they have the right key, and what if I change the key? What if a key is compromised? So the key management becomes a key issue there for symmetric algorithms. In asymmetric, it's a little bit different, and many of you are familiar with this because even though you may not know it, it deals with things like public key, private key cryptography, which you see in HTTPS. What a public key, private key cryptography does, or cryptographic algorithm does, is the server will actually send the client a public key. And the message that gets sent across is encrypted using that public key. So let's say a credit card. The credit card is encrypted using that public key, and then it gets sent over to the server. Once it gets sent over to the server, the only way to decrypt it is using a private key. This is why you have this public and private key. So I can disseminate the public key, or a single public key, to everyone in the world. And there's no way to use that public key to decrypt the message. The only thing that will decrypt it is the private key. So my key management problem is reduced to a single private key. All I need to do is ensure that my private key is not compromised. So these algorithms are used quite extensively. There's been a lot of different things about which one is more secure, which one is not secure, which is really not for this class. But one of the key concepts with encryption algorithms is that you must be able to give everyone the algorithm, and an encrypted text should not be decipherable by simply knowing the algorithm. It must be based on the key. So all of these algorithms are basically widely available on the internet. You can actually get the code, you can understand how it is, and everybody tries to break them or find these little things that breaks them. One of the key things that each one of these algorithms has is generally they're based on some concept of mathematics. In the case of asymmetric, prime numbers are a very, very key element of encryption algorithms because there is no pattern to prime numbers. And then a little caveat there is a hypothesis called the Riemann Hypothesis, which is a mathematical hypothesis that basically has not been proven, but has a predictive model for prime numbers. If someone were to prove that and literally able to do this with any prime number, with significantly large prime numbers, be able to predict the pattern of prime numbers, it would render almost every encryption algorithm based on prime numbers useless. There is a $1 million prize out for it, so anyone who's interested, feel free. It's a very interesting prize, a very interesting hypothesis. Again, it's called the Riemann, R-E-I-M-A-N-N hypothesis. So this is what this looks like. What we do is, here we have a consumer. We're going to send an encrypted message. We use the merchant's public key, which is sent to us when we make the HTTPS request in our browser. That message is encrypted, sent over the internet, and is decrypted using the merchant's private key. So there's no way to actually get that. There's no way to decrypt, the message using the public key, which is the only thing that's widely available. In the case of a digital signature, it's a little bit different because the consumer has a private key. And what happens is we encrypt it with the consumer's private key, which will then get decrypted by the consumer's public key, and the merchant will get it. Again, this is for identification purposes. We can only create a certificate using the private key. It can be decrypted by the public key. This ensures that the consumer is who they say they are. And what a digital certificate actually contains is it contains the user's name and the user's public key, and the digital certificate, which is created by the combination of the user's name and the private key, as well as some other key information on the algorithm that actually creates this digital certificate, which is just a stream of data that gets sent and then deciphered on the other end. So this is a cat and mouse game. There are hardware tools, locks, security cables, secured buildings, dedicated database servers not connected to the internet, backup systems, security cameras. These are hardware functions that are used in computer security. There's a story that I'm familiar with where an individual was concerned that someone had actually come into a server room, and they were basically just looking at ways to secure the room by using a laser pointer to know if someone came through, take the keyboard out, take the disk out to prevent access, and use some fingerprint biometrics, when a simple solution would have been to have a lock on our door, which we didn't have at the time. This was about 15 years ago. Software tools, security modules built into operating systems. Monitoring is the key thing. One of the ways you can find attackers is by monitoring abnormal activity. Are there a large number of requests? Are there requests going to an area of the environment that shouldn't be? So monitoring is a key thing. Security scanners observe traffic activities for entire networks. Do we see an abnormal amount of activity? Do we see activity that is an abnormal attacks, or abnormal activity on a particular system? There is software for intrusion detection, which literally looks for people who are probing. So there are certain fingerprints when people probe. What ends up happening is that they try multiple passwords, or they try one password and come back from a different IP address using the same password, using the same ID, those types of things. Packet sniffers search for illegal content, Trojan horses, viruses and worms, password crackers and security analyzers. There are pieces of software on the internet that will crack Windows passwords. I don't know how legal some of them are, but I know they exist. And there are other ones that actually just try basic dictionary attacks. They'll create a dictionary, and you'll get that with the software and see what you can attack. Now, those tools, there is a legitimate use for those tools because some security analysts within companies will literally run them against people's IDs to determine whether or not their password is easily cracked or not. And they may even try, and then if they're successful, they lock them out and say, you need to change your password.